This particular slide introduces a variable which I think is pretty crucial for understanding various issues related to plug-in vehicles overall. And that's not the trip length, but the length of the distance traveled between two charging events, right? That is a crucial quantity because that really tells you whether the size of the battery is sufficiently large or whether you could do better with a larger battery, or whether you could do better if you were able to charge more often, right? So that's what this is showing. The effect of the distance between charging, or plotting the fuel economy as a function of distance between charging, is pretty dramatic. If the distance between charging is below the range of the EV range of this particular battery, then of course the numbers that we are getting are very high, right? This is no longer trip distance, it is distance between charging events, right? And then as you go further up, if the distance between charging events is very high, the effect of the battery just tapers off, and you're going back down to close to what the regular Prius would actually be doing. What is interesting for this data set here, at least for Boulder, to note is that the distance between charging is less than 13 miles, which is the EV range of the vehicle, in more than 50% of the cases. So again, for this particular environment, the size of the battery is actually not that small. More than 50% of the cases, you have the distance traveled between charging events less than the size of the battery would allow in the EV mode. The average value of the distance between charging for Boulder was 22 miles. The average value of the distance between charging for the US-wide demo study was 31 miles. And again, I can reiterate that this is an important quantity because it does allow a discussion of how large the battery should be. But I think even more importantly, it does allow a discussion of how often you have opportunities to charge. So you have really two alternative scenarios to pursue. One is to have a relatively small battery and more opportunities to charge, or to have a relatively large battery, and then you don't necessarily rely on the charging infrastructure to support that. Those are two things that we can perhaps discuss as options of what could be done further to reduce further the use of the gasoline as the energy source. All right, so here is, now we're going into where the charging actually occurs. And this will be interesting, I think, to look at as well. So finishing a trip, for about 40% of the cases, you finish a trip at home. About 60% of the cases, you finish a trip outside the home, right? Out of those trips that finish at home, a little more than half end up with a charging event. So, people come at home, they plug in a little more than half of the cases. So this number right here shows you that there is an opportunity to do more, to do better, right? Why not, 100% of the time charge at home whenever you actually come at home? And that no charging at home, of course, presents a number of issues of what could be done to, in fact, increase that, reduce that number down, so that whenever you have an opportunity to technically charge, you actually make use of that opportunity. And there is a number of real-life limitations that come into play, one of which I will actually talk about in the next slide. Out of the charging events that happen at home, most of those people did make at the smart plug, and a few at some other plugs at home. So we know that the location is at home, but the smart plug did not record the electricity consumed, and so that means the electricity was taken from some other location in the house. Now, when you look at outside home, so parking a car outside home, you have a trip has ended outside home. We basically have a case where there is no charging happens. Very few charging events outside the home, and that, in addition to the real-life limitation that we have to keep in mind, is also a result of simply not having charging infrastructure present at this time. Barbara will later on talk a little bit about the charging infrastructure in the city of Boulder a little bit. it is certainly not at a point where you can just easily go around and plug in a vehicle to charge up. It is possible to do it, but it's definitely not the convenience or availability level that would make this number here more robust. So overall, for this particular period of time that we have data recorded, almost no charging happened outside the home. Some did, but not a very significant number. The last item right here, I think, is important. Out of all trips, ending all trips, about 27% are followed by a charging event, right? So we have a room to move this number up, right? This is one way of handling, displacement of oil further, even with a vehicle that has this size battery, right? So you don't necessarily have to increase the size of the battery. Instead, you can make the charging opportunity easier, more convenient, move this number up, and achieve perhaps better effects than simply increasing the size of the battery. Yes?
I left my house, I went to the store, so I parked the car, I bought a loaf of bread, and I came home. That's a trip that finishes at home.
Right.
I left my home, I went to school, I parked my car all day long, I came home. That's 2 trips.
No, these are two.
Finished outside the home?
These are 2 trips there. One that finished outside the home.
Yeah,
the other one didn't finish at home.
Well, so what's the determination? The amount of time you're parked?
Right. So
when I went to the store, I only parked a short time, so that the whole thing counts as 1 trip.
Right. So 15 minutes is the pause that we count as stopping between the 2 trips, right? So if the stop time is less than 15 minutes, we count it as 1 trip. If the parking time is more than 15 minutes, we count it as 2 trips. Why 15 minutes? Well, you can argue. You can do any other number. But 15 minutes, if you had actually, a DC charger, you could actually charge this vehicle up in 15 minutes for that matter. It's just theoretical, right? All right. So now related to this, real life limitations to whether you actually plug in the vehicle or not. And remember, this is a pretty well-motivated group of people in Boulder. What we have here requires a little bit of explanation, but I'll try to do that so you see what's going on. So we have split this events of parking and charging in 3 categories here. One is parking at home, the other one is parking away from home, and the third one is everything together, right? And on the horizontal axis here is the time, how long you actually spend in parked at this location. So, here at home, your parking is less than 1 hour in 20-something% of the cases, right? Now, in those cases where you have less than 1 hour, the vehicle is parked, the percentage of charging events is this black box right here. So a fraction of this bar where the charging does occur, that's the yes case, is shown as the black portion of the bar, right? And so you can see what is perhaps intuitively clear, but the numbers are interesting to look at. It is clear that the shorter time you have available, the less likely you're going to actually plug in the vehicle. And you yourself and myself, we can think of that. You don't have time to think about it, right? It's a matter of plugging this cable out and plugging it in. And it's not really difficult to do that, but your mindset is such that you just don't think about it, right? And so for short parking times, at home even, where you definitely have the capability of plugging in, the percentage of charging events is relatively small. When you know that you're parking over long periods of time, and most typically those would be overnight, parking in the garage, the percentage of charging events is actually relatively high, right? Now, a similar plot is shown right here for the parking outside the home, and that's actually where we can think of opportunities for charging infrastructure. So in this case here, we really didn't have good opportunities for charging away from home. And the percentage of charging events is relatively small, no matter how long you park, right? But you can also see that these white portions of the bars are clearly opportunities to do better, right? So if the charging infrastructure was in better shape, these could fill in fairly easily right here. Let's say if you're spending 2, 3, or 4 hours at a certain location, and those locations would typically be locations where people go to work, right? So and people have in fact said that in the interviews, is that they would really appreciate the opportunity to plug in the car at work, right? That's pretty normal, right? But you see how much opportunity there is in just the charging infrastructure right there. And again, not be obsessed with the battery size, charging infrastructure again being the important part of it as well. And then the overall, shows the trends that we have already talked about. The longer you have the vehicle parked, the more likely you are going to charge. This is a combination of these two results. All right. And then finally, we have a graph that shows the time aspect of the charging. When does charging actually occur? And this is done for 2 different groups that Barbara has talked about. The one group was managed, and that's these red bars, and the other group was unmanaged, the blue bars. The blue bars, right, are the people who plug in whenever they like. And the shape of that curve shows you when people are more likely to plug in at their location, in the garage. So it has a little bit of a bump in the morning, so you have done a commute, come back home and charge right here. Then it has a relatively flat right here, and then another bump probably when you're coming back from work. So not terribly surprising, but interesting to see. Now in the managed group here, there were really 2 different managed types here. One that had a pre-programmed plug that had a default 10 p.m. as a start time when it's activated. And so it is not surprising that we have a high bar right here at 10 p.m. The other group is probably associated with time of use people who figured out that they're going to be turning on their smart plug at 8 p.m. when the electricity cost goes down. And so the motivation by taking electricity at a time when the prices are lower is clearly going to be visible, and Barbara is going to be talking about that. And that's another big bar right here. But you're quite right. If you say, well, this is managed, right? This could actually have a counter effect on as far as the grid is concerned, especially, let's say, distribution transformers. They may just blow up if everyone in the neighborhood had a car that has a programmed time at exactly the same time. This, in terms of management, is very rudimentary, right? There's a lot of work going on around how to manage really charging so that the impact on the grid is reduced. And this is one particular example that this is, of course, feasible in real life, and people, did not feel terribly excited about it, but they went along with it. And what is also interesting about this is that when you look at the results in terms of miles per gallon for the 2 groups, they're statistically not very different. So management of charging did not statistically importantly affect the performance of the vehicle. Now, we have to be a little bit careful about that, and maybe this is just for this particular sample, but for this particular case here, we can say that the management actually did not affect the vehicle performance that much. All right. So just a quick summary, I'm going to turn this over back to Barbara. So overall, fuel economy, as you would expect, depends primarily on the trip length and the frequency of charging. In Boulder, the trip lengths turned out to be actually shorter than we thought it would be. Around 88% of the trips are within the vehicle EV range. As you can think of this, right? If every single place where you stopped had a very convenient, easy-to-use charging, these vehicles would be just as good as EVs, right? Now, we are very, very far from that, but you can see that that's one possibility of moving forward. Electricity for the actual recorded data set displaces about 30% of the total energy consumed per mile, up to. And in Boulder, about 27% of trips are followed by charging events, which again presents opportunities for better technologies for charging and simply charging infrastructure.